So in this problem, we have a triangle with all the values rounded to 1 decimal place. Find the lower and upper bounds of the triangle's area and its perimeter. Right, let's do some labelling. So if we call this angle A, so this side is lowercase a, then we can call this side lowercase b and that side lowercase c. Now, obviously what we've been doing so far with upper and lowercase letters, I'm just labelling that in the format that you're used to when you're labelling a triangle. So recognise that all 3 values that are there, 3.7, 102.3 and 5.6, are all rounded values, regardless of the fact that I have labelled them lowercase or uppercase, okay? So, first things first, we need to find the range of values for each of these. So, let's start with the angle, okay? So, capital A, so I'm going to use capital letters here, just so we know what we're working with, so A being an angle. That can go from anything from 102.25 degrees up to 102.35 degrees, not inclusive. B, so side length B, can go from 3.65 to 3.75, and C can go from 5.55 up to 5.65. So for the area, of a triangle, we're going to be using half AB sine C, okay? So that's the formula we all know, but with the lettering that I've got, I won't be using C. I'm going to be using 1/2 BC sine A. Okay. So, the lower and upper bounds. So the lowest the area can be will be utilising the smallest possible sides, the shortest possible sides, and the smallest possible angle, okay? So, and make sure you calculate in degrees when you're doing this, we're going to have 0.5 times 3.65 times by 5.55 times by sine of the smallest angle. So sine of 102.25. And so that's 9.89812957. The upper bound, the largest the area could be, would be coming from using the longest sides and the largest angle. So that would be half times 3.75 times 5.65 times by sine of the largest angle, so sine of 102.35. So that's 10.34860319, not inclusive. And so these are the lower and upper bounds of the triangle's area. Okay? And that'd be in units squared, or square units rather. Okay? Right, perimeter. Now for the perimeter, we're going to need to know the length of A. In order to do that, we're going to have to use cosine rule, the cosine rule. So we know that A squared is going to be equal to B squared plus C squared minus 2BC cosine of the angle A. So the value of A is going to be the square root of that right-hand side. Okay? So A can go anywhere from, so we're going to use the smallest value of B, the smallest value of C, and the smallest angle. So what we've got, 3.65 squared plus 5.55 squared, take away 2 times 3.65 times 5.55 times cosine of the smallest angle, 102.25. So that gets me on my calculator 52.72137.839. Square root that, and we get 7.2609488863. Okay, now for the largest possible value for A, we're going to use the largest values for B and C and the largest angle for capital A. So we have 3.75 squared plus 5.65 squared. Take away 2 times 3.75 times 5.65 times cosine of 102.35. So that's 55.04829895. Square root that, and we get 7.4194534551. Not inclusive. Okay, so the perimeter will be the sum, the lowest, the smallest that the perimeter can be, the lower bound, would be the sum of the 3 shortest sides. So 7.26094, etc., plus 3.65 plus 5.55, and that gets us 16.46094886. And the largest it could be is this value here, 7.419, etc., plus the 2 largest values, so 3.75 plus 5.65. And that's 16.81945345, not inclusive. And so there are the upper and lower bounds, or lower and upper bounds, of the triangle's perimeter.